Hi, today we've been looking at the 2015 PAT paper and going through question 13. So question 13 asks us to use your knowledge of solar eclipses to estimate the radius of the moon. Given that the sun's radius is r, which we can denote as r sub s, is 700,000 kilometers. Distance between the Earth and the Sun, which we know as d sub es, is 150 million kilometers. The distance from the Earth to the Moon, which is denoted by d sub em, is 400,000 kilometers, and the Moon's radius, r sub m, is the unknown, what we're trying to find out. So first of all, we ask ourselves, well, what is a solar eclipse? Well, a solar eclipse is essentially when the Sun is obscured by the Moon. So as the Earth orbits around the Sun and the Moon orbits around the Earth, at some point the Moon will lie such that it blocks out the Sun from the Earth. So we'll write this down. A solar eclipse is when the Sun is obscured by the Moon. Now we had to use this fact somehow to estimate the radius of the Moon. Now I would start, as you do with most physics problems, by drawing a diagram. So let's draw on our Sun. So we'll label that Sun. And we'll have the Moon. This is not the scale, by the way. And then the Earth. Now let's mark on what we know. So let's mark on that the distance from the Sun to the Earth is, as we know, 150 million kilometers. Now, for simplicity's sake in calculation, we're going to work in units of million kilometers. So we'll denote that by m. So this is going to be 150 m kilometers, where the m denotes million. Now, we know that the radius of the Sun here is 700,000, so that's going to be 0.7 m. And we know that the Earth-Moon distance is 400,000 kilometers, that's 0.4 m. Well, now we might think is, well, how are we going to get a relationship between all these values and work out our unknown here, which is r sub m, which we don't know. Well, one thing that might be useful is to think about similar triangles. So if we extend a line from the top of the Sun to pass past the Moon and to connect to the Earth, and we extend the line along the centre of the Sun to the centre of the Moon, like that. Now, we have a right angle here and here, and a shade angle. So we clearly have similar triangles here. So we can use relationships between similar triangles to find our value of r sub m. Well, we know from similar triangles that the ratio of this side to this long side here will be the same as the ratio of this side to this side. So we can write that down. So we know that 0.7 over million, or we'll drop the m now, over 150 is going to be equal to, well, the same here, r sub m over 0.4. So multiplying through, we get r sub m equals 0.4 times 0.7 over 150. Remember, this is in millions of kilometers, which equals 0.28 over 150 million kilometers. Now, let's remove the million now. So we know that's going to be equal to, well, 280,000 over 150 kilometers, which is, well, we need to estimate this. So how can we make this simple? Well, we know 150 goes into 300, or 300,000, obviously, and 280,000 is relatively close to 300,000, so that's approximately equal to 300,000 over 150, which gives us that r sub m is approximately equal to 2,000 kilometers.